Hello everybody, welcome to ZEISS Innovation Rocks. My name is Pietro. Once again, I have the pleasure of being your host, and this is Rock number 9. In today's Rock, we're going to focus on a highly topical theme, as we're going to take a closer look at the market trends for e-mobility and the so-called NEVs. And we're going to do that by talking to experts and by attending live demonstrations. But first things first, let's start by inviting my studio guest. His name is Patrick Stempfle. Hello and welcome, Patrick.
Hi Pietro, nice to meet you.
Thanks for being with us, Patrick. Why don't you start just by introducing yourself?
Yes, sure. My name is Patrick. I'm the head of application for new energy vehicle. And within our team, we drive the application development to link our customers' requirements and demands with our existing ZEISS solutions.
All right. Today's topic is going from energy to e-motion with capital M with ZEISS e-mobility solutions. But first, what does NEV stand for?
So NEV means new energy vehicle and covers all types of cars where a traditional combustion engine is either substituted or upgraded with an electrical drivetrain. For example, battery electric vehicles, fuel cell electric vehicles, or plug-in hybrid electric vehicles. At the moment, we are faced to the trend that a lot of traditional cars are replaced by the new energy vehicles. And that's why we offer our ZEISS e-mobility solutions from energy to emotion, meaning from the energy storage down to the actual movement and drive of the car. And therefore, we identified 5 core components: the battery, the fuel cell, the electric motor, the transmission, and the power electronics.
All right, well, and for a better understanding of everything here, we have prepared a video for you. This video, especially the second part, delivers a huge and highly comprehensive picture. Are we really going to talk about all we have just seen?
Oh no, that would be impossible. Maybe you have seen in the last months that we focused on the electric drivetrain and the motor. But in today's Rock, we want to focus on the most value-adding components which take the task of energy storage and energy provider, the fuel cell and the battery system.
All right, many of us, me included, have already heard a lot of battery-driven vehicles or fuel cell-powered vehicles. What is the main difference between these two technologies?
Yeah, so the main big difference is in the way they store the energy. So a battery electric vehicle saves all the energy in the battery. That means the energy is taken from the power grid, saved in the battery, from which then the drivetrain gets the energy to drive the car. In a fuel cell electric vehicle, the energy is stored as hydrogen in tanks, and the fuel cell uses this hydrogen together with ambient oxygen to generate the electricity. This is how a fuel cell works, and this is how a battery works. So the main difference is just the energy storage.
Okay, well, both technologies sound like ready for the future. Actually, they're already here. But let's come to ZEISS's role in all of this. What are the main challenges that you have to overcome in terms of quality assurance of the many rather new components that come with these new technologies?
Yeah, so as you can imagine, the manufacturing technologies for the fuel cell and the battery differs very much from what we know from traditional components. Well-known machining technologies such as milling, turning and grinding, they are decreasing. New ways to produce, like laser cutting, stamping, coating and welding, they determine the manufacturing process. So for all of these processes, it's necessary to have a quality assurance plan in order to have a safe reliability, productivity and longevity of these components. Let's focus first on the battery. So if we have a look at a battery, it starts with the raw material composition and distribution in the electrode, over electrode production, cell production and module assembly. And even for the big battery trays, which are part of a car body, we need these processes. For example, for the raw material, we have to search for tiny defects in the structure. For the alignment and misalignment in battery cells, it's important to have solutions. And also for the big battery trays, we need hundreds of geometrical evaluations.
All of this sounds very complex, and I can imagine that many new devices, many new metrology and inspection devices are becoming essential.
Yeah.
Can ZEISS offer the total package for that?
Absolutely yes. For the battery manufacturing and the battery R&D part, we can offer for every single quality gate the right tool for measurement and inspection. So on the one hand, we can use our holistic microscopy portfolio. For example, light microscopes, electron microscopes, and even X-ray microscopes. On the other hand, we have our metrology tools, such as multi-sensor CMMs in different sizes, depending on the customer's part, or computer tomograph and X-ray systems for non-destructive testing, which is of highest importance for battery quality assurance. But why don't we have a demo together with Jay and Jehan, who is our battery expert?
Well, I think that's a great idea, and I know that our demonstrations commander, Jay, is already waiting for us. So, Jay.
Okay, so right now our task is to learn a little bit about lithium-ion batteries in regards to new energy vehicle. Helping me today is Jehan. Jehan, thanks for joining us.
Nice to meet you, Jay.
Before we dive deep into this, why don't you tell us a little bit about yourself?
Okay, my name is Jehan Lee. I'm a solution manager for lithium-ion battery in ZEISS.
Perfect. Thank you for joining us. We appreciate it. Let's just dive right in because I know that's an initiative, but I don't know much about lithium-ion in regards to e-cars. So can you explain a little bit about what we're looking for?
Yes. Recently, lithium-ion battery technology takes off with NEV initiatives. We have identified customer had challenges to correlate their material analysis to cell research. And ZEISS, we have complete solution to analyze from cell to material at multi-length scale with destructive and non-destructive measurement tools. Yeah.
Perfect. All right, so let's just dive into it, right? So what if someone were to, example, go look at a light microscope? What would that person be looking for if they were looking for this type of microscope?
This is light microscope. Basically, it uses light source to visualize lithium battery in micro scale.
Okay.
Lithium battery has cathode, separator, anode, and basically customer want to see cross-section or plain view of all the materials here.
Okay. So we're looking at 3 distinct layers of material where we excite it in different ways, and we're looking for different things. Is this, what is the scale of this again?
This is a micron scale.
Okay. And then is this destructive or non-destructive?
This is destructive.
Okay, okay, all right. So you said this is micron scale. I'm going to throw a challenge at you. What if a customer is looking for a nanometer scale?
Oh, ZEISS we have good solution with the electron source, so-called scanning electron microscope. We can visualize lithium battery material in sub-nanometer scales. Yeah.
Okay, so we're looking at the same 3 layers, getting the same information, but looking at it at a resolution at the nanometer level.
We have more details in high resolution, high contrast. We can visualize crystal orientation for cathode anode materials. Also, we can visualize, analyze coating layer on separator. Yeah.
Perfect, perfect. All right, that's destructive or non-destructive?
This is destructive measurement, but in high resolution.
Got it. I'm going to throw another curveball at you. You ready? Okay, what if we have a customer who cannot destroy their sample? They must have a non-destructive test. Do we have a solution for them?
Yeah, it's a good question. ZEISS prepared X-ray microscope. We use X-ray source. We penetrate cell. We use intact, non-destructive measurement tool. We can visualize inside cathode separate anode all together in sub-micrometer scales.
Okay.
ZEISS has a good scintillator objective lens. We can zoom inside in
All the way in.
almost nanometer scale.
Perfect, perfect. So if I'm hearing you correctly, Jaehan, we have a suite of products that can help someone that's looking for lithium-ion applications in the NEV field, both from destructive, non-destructive, micron or nanometer scale, both equipment and knowledge, yeah? Jaehan, if anyone has any questions, is there anywhere they can go?
We can explore webinar for lithium battery. We have other experts for lithium battery.
Okay, perfect. And when is that webinar?
So right after this show. Yeah.
Perfect, perfect. All right, so thank you for joining us and explaining I know I learned a lot, to us about lithium-ion batteries. Appreciate it. And with that, I will turn it back over to you in the studio.
Thank you very much, Jay, and thank you very much, Jaehan. Well, I must say it's cool to see all the different solutions that you offer for the various steps in battery production. And speaking of battery production, I know, Patrick, that Asia is one of the most important markets for that.
Yeah, that's true. And that's why we established our NEV Competence Center in Shanghai, where we focus on the battery application. What do you think about having a connection to Bob Chen, who is our global project and commercial leader for the NEV?
Well, I think that we should definitely do that, so let's connect with Shanghai, China, where Bob Chen is waiting for us. Hello, Bob.
Hello, welcome to Shanghai NEV Competence Center. This area is for industrial microscopy. We utilize this technology to help customers improve battery material quality. Then we go into the area for CMM. This machine could provide inline etching solution for battery tray. Next one is industry CT. We could provide intact solution to measurement battery cell and battery module production.
What do you think if we have a small chat about the Competence Center?
Sure.
So our first question is, how do we collaborate with our customers in terms of battery application, and why did we build up the Competence Center in Shanghai?
Sure, Patrick. As you mentioned, the battery market is expected to grow more than 20 times by 2030. At the same time, battery customers are facing many problems in production efficiency and quality measurement. In order to follow this current trend in automation industry, and to meet the new challenges of our customers, we from ZEISS decided to expand our capability to build up an NEV Competence Center in Shanghai to close with our customers.
Okay, thank you. Bob, can you give us an example how we create value for our customers and how we solve their problems?
Yes. We create value by understanding customers' requirements instead of promoting our existing solution. Our application consultants spend most of their time visiting our customers, stay with them, understand their process, their problems. Then they bring their problems back to our competence center. We develop a dedicated, customized solution to solve their problems. The key is to think out of the box. If our current portfolio cannot meet the customer's requirements, we kick off a new project for innovation.
Okay, this means that all the work we do is totally customer and application driven. Bob, can you give me a small outlook for the next months or years with the Competence Center in Shanghai?
Yes, the cooperation between ZEISS and our customer is not limited to the specific project. It goes beyond to also exchange talents for their growth. We are also planning to cooperate with universities, institutes as the next step. The rotation programs open the door for future technology for all of us. We are targeted to build the world-class competence center to create value for customers and ZEISS.
Thank you, Bob, for sharing these insights. Looking forward to see you. Highly appreciated.
Welcome.
And from my side too, thank you very much, Bob Chen, and to your team, and best of greetings to Shanghai. Well, Patrick, it looks like that ZEISS got everything they need to satisfy customer needs all over the globe. But let's come back to the fuel cell, Patrick. Can you give us some more concrete applications examples? Or maybe can you name some of the main challenges you have to overcome?
Yes, sure. So the fuel cell system itself consists of so many different subcomponents, such as humidifiers, pumps, valves, pipelines, and other peripheral components. But the heart of the fuel cell is its stack, which includes the membrane electrode assemblies and the bipolar plates. In the fuel cell stack, the reaction between oxygen and hydrogen takes place to generate the energy. And that's why it's very important that the fuel cell is connected in a row, and that means if one cell is defective, the whole stack's quality, reliability and performance fails.
Okay, and what are the characteristics of the components of those fuel cell stacks that need to be checked and controlled?
Yeah, so the membrane electrode assembly's main quality gate is the coding analysis for defects, and additionally the 2D geometry for the single layers. Therefore, we use our microscopes and our O-inspect, for example. For the bipolar plates, they are made out of stainless steel, graphite, or even composite material. The main challenge here is to check the geometry of the flow field, which is responsible for an unhindered gas flow and of the coolant. And that's why we use different technologies to check the bipolar plate.
For example?
For example, the Prismo. So we have a short demo on the Prismo.
Well, this time we have pre-recorded it because it's with Jay and with Patrick, so let's have a look together.
Patrick, how's it going? Thanks for coming out. You and I have been right here before talking about NEVs, so I understand you're going to show us something new.
Hi Jay, yes, that's correct. Today we will have a closer look at the fuel cell application. In detail, we will discuss about the bipolar plate, which you can see here. The bipolar plate is an essential part of the fuel cell stack and very critical for quality assurance.
Understood. Hey, I was having a look earlier about the stack, and it looks like these details are really, really tiny. How would we measure that?
Yeah, that's right. The radius, the flank angles, the whole curvature is a real challenge for metrology. And what you can see here, we are using our optical sensor, the dot scan. And with them, we are able to measure all the single microstructure details with the CMM, with a multisensory CMM, our Prismo.
Absolutely. So it is the fact that we use the dot scan that can get us these details. Got it. All right. Another thing that I noticed, because it's right there, is we actually fixturing this in a vertical position. Wouldn't it be easier to just kind of lay it flat on the part to measure it?
Yes, you're right. That would be easier. But customers' requirements are different. And it's depending which parameters you're interested in. So if you're interested only in the microstructure, lying flat on the granite is good enough. But if you're interested, for example, in the microstructure material thinning, or if you're interested in the lateral alignment of welded bipolar plates, then you need to make sure that you can reach, like you can see here, from both sides, the bipolar plate.
That's right. So to be able to get to both.
Yeah.
All right, so next question. It's a really nice fixture. Did we buy that, or how do we get this fixture?
No. This is a ZEISS designed fixture and also manufactured by ZEISS. The idea behind that is that it's not enough just to sell a system, a sensor, or a software. We also take care about the full application and the full solution. And the fixture is one essential part of the full story.
Understood. So it's kind of a holistic package. We can provide the solution for the machine, the sensor, and even the fixturing. So we're kind of like a one-stop shop for NEV, right?
Absolutely. That's right. And on top of that, we can also add our application specialist knowledge. We have application specialists for the fuel cell application that can discuss every detail with the customer in order, in the end, to find out what is the best offline, at-line, or inline solution that the customer is able to store with our ZEISS technology their production in a safe and reliable way.
So obviously, Patrick, every time we talk, you outdo yourself by not only giving us, this time, not only giving us a holistic one-stop shop, but adding applications engineers on top. So I leave it to you because you always amaze me every time we talk. So my last question for you is, if someone has any questions, what can they do?
Yes, we are prepared for that. We will run a webinar session right after this show.
Okay, so, well, thanks for that, and I appreciate that. So with that, we're going to send you back to the show.
Thank you, Jay.
All right, see ya.
Thank you very much, Jay, for this demonstration. Patrick, to wrap this thing up, let's play a little game. I give you 10 seconds for a final comment on ZEISS e-mobility solutions.
Okay, well, so I would say ZEISS is totally customer-oriented. We develop our application solutions according to our customer needs to serve the full package to our customers from energy to emotion.
Perfect. Very well said. Thank you very much, Patrick Stempfle, Head of Application for New Energy Vehicles at ZEISS. And with that, ladies and gentlemen, we have come to the end of ROC number 9. Our webinars will start right afterwards. Don't forget to click the link below to register for free and to be part of it. A big thank you to you out there for tuning in. My name is Pietro. It's been a pleasure, and I'm looking forward to seeing you all tomorrow for ROC number 10. Take care and bye-bye.